Okay, this tutorial is really going to cover a number of things. Number one, I want to talk about z-scores and how the calculator applies to that. I want to talk about area under the curve and how it relates to probability. And also, how do we use the calculator to find these values? How do we find the calculator to find two specific ones? How do I find it? How do I use it to find the area under the curve, just like I would use a z-table for? And how do I go backwards and find z-scores or the original x values of the problem? For our example, we're going to look at an IQ distribution. So some IQ tests are standardized to a normal model. We've mentioned something similar in class. We have a mean of 100, and we're going to have a standard deviation of 16. So the first thing I wanted to do was kind of relate it back to something we've already studied, the 68, 95, 99.7 rule. We want to basically show how it would predict values for certain distributions, or for this particular one. So what we can do is we can see that we have the 68, 95, 99.7 scenario. We know that the 68% of all data is going to fall between one standard deviation on either side of my mean, which is located here in the center. 95, if I go two standard deviations out, then 95% of all the IQ scores I would collect would fall between whatever values would be at these marks. 3 standard deviations out on either side, above and below the mean, I'm going to have 99.7% of all IQ scores to fall into this range. To make this apply to the particular situation, we go ahead and we put the bottom, our mean, we add our standard deviation 1, 2, and 3 times, and we subtract it once, twice, and then 3 times. And so this would be the numbers that would correspond to the whole number standard deviations away from my mean. So if we converted this to z-scores, then the mean, of course, is 0. It is exactly at the mean. That's 1, 2, 3. And I go backwards, -1, -2, -3. So hence, if I were to tell you you had a negative z-score, then that would automatically tell you that I'm below the mean, whatever number of standard deviations away that would be. Positive z-scores indicate information that's above the z-score, or above the mean. So there's the first question. This is a very basic one. What interval, that means beginning to ending, so you're going to need two numbers, would you expect the central 95% of all IQ scores to be found? Well, that's pretty obvious. It's kind of sitting here. Well, it would be between 68 and 132. So 95% of all IQ scores in this situation would fall between 68 and 132. All right. The next question. What percent of IQ scores or percent of people should have an IQ above 116? Well, that's easy enough. I go up here and I say, okay, well, what percentage would be from here up? This is one full standard deviation above the mean. If I think about it, I know that the mean divides it into half. So 50% below, and I know that this part is 34%. So if I add 50% from the 100 down plus my 34%, that makes 84% total, right? Well, I don't want to know below that. I said what would have scores above 116. So if that's 84% down here, then since it's 100% total under the curve, then the other side of that would be just 16%. If you remember from class, we divided these little tiny pieces up into the different sections. So you had 34%, you had the 13.5, the 2.35, and then the 0.15, or which would be the total percentage under each little section. Don't forget about that. You need to know those things. The next question requires us to do a little bit more digging. So what I've done in this case, I've included my z-score formula. Now, why does this require you to do a little more thinking? I've asked the question, what percent of people have IQ scores below 80? Well, normally we'd go to our little curve here and we'd look up here and we'd find our number and we'd just add up those percentages that we just talked about. Unfortunately, 80 is not one of my numbers. The next question also poses the same problem. between 85 and 125. Well, if it was one of these numbers, I could just find it and add the percentages up in the middle. Unfortunately, 85 is now just slightly larger than that one, and 125 is right about in between here. And do not ever think, oh, look, it's halfway. I'm just going to divide by 2. There's way more area on this side than on this side, so it is not like a square or rectangle. You can't do that. Okay, if your values that you're interested in do not occur on a whole number standard deviation way, then we are automatically going to have to use a z-score formula. We're going to have to use our tables, or we're going to have to use the calculator to discover what the percent or the probability of the area under the curve is going to be. Now, I'm going to go through this using the calculator. We'll do the other one, or should have done the other one in class by now, or we'll do it later. So just refresh your memory, the z-score formula is here. That's my z-score equals the actual x value, well that would be the numbers I'm given in the problem, here in this case would be 80, minus the mean divided by the standard deviation. In this case the mean is 100, the standard deviation is 16. So I've got a couple of screenshots of the calculator. I'm going to do this live as well, but let's just stop right here. If you will look on the side, the calculator, in order to find all of these commands that I'm going to look up under area, it's second and vars. It's right next to the clear button, but you have to press second first. If you look up the blue button, it's the actual menu I'm looking up is the distribution menu. And so here it is. You see that you have normal CDF, normal PDF, normal CDF, inverse norm, inverse T, TPDF, TCDF, and some other ones as it keeps on going. Now I will call your attention to some of these. Inverse T, if you have a TI-83, then you will not have this option. That's a significant drawback, not right now, but eventually, if you can't update your calculator, then that's going to be an unfortunate thing. So, but we'll talk about that later. What we're interested in is this one right here for now, Normalcdf. What that means is I'm going to be looking at a normal distribution, and I want to add up, or I want to find the cumulative area under a certain interval of values. So I've got it highlighted right there. If you want to know what you're going to type in, then this is kind of where you type it in. It's the lower bound, the upper bound, comma, mean, comma, standard deviation, and then comma in between all those values. And so we're going to do that. I'm going to go down to number 2 and select Normalcdf. The first thing I want to type in is the lower bound. Now I will say this, if you have a really new calculator, then your screen's going to look a little different than mine. You'll actually have it written out for you, lower bound, upper bound, mean, standard deviation, which is even nicer than what I've got here. But we'll just go ahead. Our lower bound, well, I've asked you for everything below 80, so that means that it goes forever. And so really what I need to do is just plug in a big number, and rather than trying to tell you, we'll just pick a really, really big number, and it changes every time. We're going to be something specific, and we're going to pick negative infinity, or at least as big as the calculator can go. So we're going to choose a negative 1, and it's going to be E, which is right here, but I got to press second first. So second, it's really the comma button. That's E, that's times 10 to the 99th. So basically that's effectively negative infinity as far as we're concerned. So comma, the upper bound, well I want to go all the way up to 80. And then my mean, which is 100. And my standard deviation at 16. Double check you typed your numbers in right. That's negative infinity to 80 at 100 and 16. Close my parentheses, and then I will hit enter, and it will return back to me the area under the curve. So just a little over 10.5%. If we look at that, we've got that down here. I even included a picture of the curve. So what we're looking at in this case is your normal CDF, which I have the intervals, the values that I put in here. Then I have the area under the curve. This is a picture of what that looks like. How do you find the area under the curve? Okay, it's just this normal CDF. So you would expect, what percentage of people have an IQ below 80? You would say just under 11%, or right at 10.5%. Okay, the z-score would be negative 1.25. If I were to actually use the z-score formula, then I would get the negative 1.25. I wasn't really interested in z-score. I wanted to know a percent, what percent of people. Find that probability and then convert it into a percentage. Second question says, what percent of people would be between 85 and 125? Remember that we had upper and lower bounds. There's my lower, there's my upper. If I type that in again, you can see I've got that screenshot here, 85 to 125, and of course the mean and standard deviation stay the same. You can see that 76.67% of the area falls between that. And you would think that that's a fairly large percentage. It's going to be more than, if we go back up to the top, it's going to be more than 68% because it's 84, just past that, right? So we're looking at 85 to 125. So it's going to be more than 68%. And that's totally confirmed when I have almost 77% here. All right, the last question is a bit different. What IQ score? Notice how I changed the question. It's not what percentage, but it's what IQ score. Well, that's the original units of the problem. It's IQ scores. So immediately you've changed the problem. I'm not looking for an area under the curve. I'm not looking for a percentage. I'm looking for an original, like an X value that I would type in. Our X values that I typed into this problem was 80. It was 85 and 125. So I have to change my method. I can't use Normalcdf. I put it down here. Normalcdf is to find area under the curve, or probability. invNorm, that's what's in yellow. If I want to use that, then I can find z-scores or the original values in the context, or x values. And so we'll do that one as well. So that's in the same place. Go back to second, vars. It's going to be right here, invNorm. So I'm going to go down to 3. I'll hit enter. And now this one's a bit different. What you type in is, I want to type in the percentile. Now notice I gave you the percentile here. invNorm finds the values, but you must use an area or percentage. You got to convert it to the decimal from the left cumulative to up to whatever number you're looking at. In this case, we want to know the 99th percentile. The very first thing you type in is the cumulative area from left to right. It does not work any other way. Okay, and they'll type in comma the mean 100 comma standard deviation at 16, and I close my parentheses. That's all I have to type in. So that was percentile area as a decimal, comma mean, comma standard deviation. I hit enter, and it shows me that in order to be considered in the 99th percentile, I would have to score, I have an IQ of at minimum 137.22, and if they only give you a whole number value, then I have to round that all the way up to 138, because if I were just at 137, then I would be slightly below the 99th percentile. So in this case, if we just want to be specific, it's 137.22 would be my actual IQ score. So the two things we covered were Normalcdf, finding area under the curve, probability, as well as finding, well, let me do one more thing. invNorm, let's say I wanted to find the z-score. So since I have the z-score written here, let's find the z-score for 80. We already know what the percent area is. It's 10.56, so let's type that in. So we'll do invNorm. So second vars, invNorm. So 0.1056, comma 100. We're going to see if this gives me approximately 80. It probably will round to 80 because I've estimated that decimal value. So we hit enter. It should be exactly almost right at 80. So that's just another way of confirming that this does give me back to what I started with here. Make sure that you know how to use this calculator method. This is absolutely critical to be successful in the upcoming chapters, including Chapter 6.